Hey students, this is the unit on climate change lecture video. We're going to be talking a little bit about a lot of stuff in climate change, and this part focuses on how we contribute to climate change. We're going to talk about the differences between the terms global warming and climate change, look at greenhouse gases and their role. Just look at these unit objectives, and these are the things that you should have some knowledge of by the end of this unit. Well, we're going to look at what is climate change. We're going to see what is the role of climate change, what are the consequences, and then how we can address it. This is a really good kind of infographic here on land and ocean temperature percentiles. And if you look across the world at record warmists, the whole thing being mostly shaded either pink, dark pink, or red means that all over the world, the average temperatures are much warmer. So what is climate change? When we talk about climate, we're referring to the average weather patterns in a given area over time. Weather is a daily thing. Often we hear people talk about, if it's really cold in April, you hear some people say, oh, this climate change is nothing. Well, a daily fluctuation in temperature is just weather. But if you look at the whole pattern over long periods of time, that's climate. And we typically look at temperature and rainfall to describe the climate. Where we live in the springtime, it's typically kind of cool and rainy, and in the summer it's hot and humid. That's what we mean by climate. And all over the world, there exist these things called biospheres that exhibit different climates. And those biospheres are typically kind of defined by the climate that they're in. Well, why are climates where they are? If you look at the equator of a place, of the Earth, that's where most of the rainfall, the rainforests are. And it's hotter at the equator. And one of the reasons is that if you look at the sun, the sun shines its light in a more focused area at the equator, but near the poles, that sun is spread over a larger area, and so therefore it's cooler as you move from the equator north and from the equator south. It gets cooler that way. Well, there's some ecological terms in a biosphere. What is a biosphere? And a biosphere is made up of, at its lowest level, populations. These are organisms of the same species living in a particular area. A community is a bunch of species all together. An ecosystem, so these are all living things. And an ecosystem is living and non-living. And the biosphere is the sum of the regions of the Earth where living organisms are found, and that's basically everywhere. Well, since the 1980s, the average temperature of the planet has been increasing. We've kept pretty good records, since about 1880, and around 1960, the trend has been upwards, and you can see that it fluctuated here. It got much colder. This was called the Little Ice Age. But as you go, once we get to around 1980, you can see we have a very, very, very large increase. Now, it's an increase of just a couple of degrees, but still, this is a pretty drastic incline. Well, what is the relationship between climate change and global warming? So a number of weather events such as extreme precipitation and heat waves are correlated with climate change, and while others like tornadoes we're not really sure about the connection between that and climate change. But there is strong evidence for the Earth getting warmer, to have severe droughts in areas, severe precipitation events, so, kind of the opposites of each other, heat waves, coastal flooding. Coastal flooding due to rising ocean. The ocean levels are rising. We've been measuring it for quite some time. And the term global warming was one of the first used who discovered the trend, and it's still often used interchangeably with climate change, but they're not exactly the same. All right, global warming is associated with increases in surface temperature, and climate as being the average weather patterns, and climate is often recorded as temperature and precipitation. So what is causing the Earth to get warmer? Well, it's probably because of greenhouse gases. And the reason we call them greenhouse gases, if you look at a greenhouse, a greenhouse is typically, that is a terrible drawing, sorry, but a greenhouse is typically made of glass, and when the sun shines its rays, light travels in waves. And when these waves pass through glass, the waves get bent and they get stretched. And so high energy waves, like little short wavelengths, can travel right through glass. And so what we have are little short wavelengths. Once they get into the greenhouse, those wavelengths get stretched out and they no longer have the energy, so they just bounce around inside the greenhouse. And you can feel this effect in your car in the summertime, when you're out and it's hot, and then you get in your car, it's much hotter inside your car. And the reason is that there's a lot of heat being trapped inside your car because it got through the glass because it was high energy. The glass bent it, and it can't escape back out again. Well, the Earth is covered with an atmosphere, and if you kind of think of the atmosphere as glass, then if you have, the Earth here, and then we have this layer around it, if you make this layer thicker, then what happens is you trap more heat inside. And that's what's causing the Earth to get warmer. This is a much better drawing than what I just did. But there are some greenhouse gases, water, which, there's precipitation comes from there. But this is one of the main ones: carbon dioxide, methane, nitric oxide, ozone, and then CFC. CFCs have been decreasing over time because we don't use those chemicals in refrigerants anymore. But we do put a lot of this into the atmosphere and a lot of that into the atmosphere, which causes it to get thicker. Well, carbon dioxide is found in small concentrations in the atmosphere, but it also is really good at absorbing infrared energy. Carbon dioxide is produced through fires, volcanic activity. You breathe out carbon dioxide. Your car uses fuel, which releases carbon dioxide. And so for centuries, atmospheric carbon dioxide had never been above this line here. It goes up and down, up and down, up and down, up and down. And right now, it's higher than we've ever recorded it. And we can measure carbon dioxide from many, 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 many years ago through the ice that we find in the poles. You can dig down, date the ice, and see how much carbon dioxide was in the ice, and we can extrapolate that data and figure out how much atmospheric oxygen there was. Well, another one is methane. Methane's pretty rare, but it's also unstable, and it remains in the atmosphere for about a decade. But it's still a powerful greenhouse, and one of the things that produces a lot of methane is livestock. Water vapor is natural, and that's not a greenhouse gas that we're really concerned about. But nitrous oxides, like in fertilizers and burning fossil fuels. Ozone's another kind of natural process, and ozone is one of the things that we need to keep ultraviolet light out that causes sunburns and stuff. But these are a list of the greenhouse gases. So what is some of the evidence of climate change? Well, sea ice is decreasing. The temperature of the sea surface is increasing. Sea levels rising. The temperature over the oceans is rising. Air temperature near the surface is rising. We've had more extreme weather events than we've ever had. Glaciers are decreasing. Temperature of the land is increasing. So, if just a couple of these things were happening, we could say, well, maybe, there's climate change is kind of a natural event and it'll just kind of go back down. But all of these things that you would predict with climate change are actually happening. When carbon dioxide enters the oceans, it produces carbonic acid, which leads to ocean acidification. And we have seen an increase in the acidification of the ocean. So the pH is going down, which means that you have less shells and other hard parts for mollusks, and we've witnessed that. Fish are negatively impacted as well. So this increase in acidity decreases the amount of carbonate in the oceans, and that's why you don't get shells for crabs, lobsters, and clams. And the ocean acts as kind of a heat sink. It absorbs a lot of heat. It's temporary storage, and then those heat sinks are not unnatural, and they account for moderate temperatures in Florida. So, along the coast, and especially like San Diego, I don't know if you've ever been, but it's beautiful there. But San Diego, the average temperature is about 74. And one of the reasons is that the ocean out here is absorbing a lot of heat. And because it absorbs a lot of heat, then what you have are these really mild temperatures right on the coast. But as you move inland, so if you moved, if you moved inland, like to here, it would be really, really hot. And it's because the ocean out here is absorbing the heat, but the surface out here is really hot because it's too far away from the ocean. So here is a glacier from 1941, and you can see how much it covered. And now this is that same glacier that's pretty much gone in 2004. This is the extent of sea ice in the Arctic. It's gone from around 7.75 million square kilometers down to around 4.25. Extreme weather, the severity of droughts, heat waves, precipitation, all of these things have been happening in the United States. And these are all billion-dollar weather and climate disasters. And all of them have happened in 2021. Well, is carbon dioxide really to blame for this increase in temperature? And this is a really great graph here. The green portion of the graph is the temperature. Temperature goes up and down, up and down. It kind of fluctuates from year to year. But if you look, and if we put on this same graph the increase in carbon dioxide, you can see it follows that pattern almost exactly. And so those two things are definitely correlated. And there's a direct relationship between the two things. And that's it for this chapter.